Good evening! If you like Arduino Uno or Raspberry Pi boards, then this video is for you. Here you see few lines of a program that controls an LED. If I add to this program few new lines, we get a system that reacts to a button pressing. This program is quite similar to those ones that are used for Arduinos, but here these few extra lines were needed because I wanted to make here a C++ program. We who use computers understand that computers need to be shut down nicely. You know that one shouldn't just disconnect the power supply of a computer as we are used to do with Arduinos. And for instance, at this program here, the connecting of a certain GPIO line down to the ground indicates to this computer that it should now start shutting itself down. But otherwise in this video we are going to use the input and output pins of the Raspberry Pi microprocessors precisely in the same manner as the Arduino Uno people use the input and output pins of their microcontrollers. And here you see my personal and current reason for today's video. I'd like to use the power, the flexibility and the network connections of a computer to control, for instance, this kind of Arduino Uno shields. So let's start experimenting. I bought this Raspberry Pi 2 board a year ago for about $20. At that time I thought that it was quite expensive, and I must emphasize that there are several cheap and good alternatives for the Raspberry Pi. But if you absolutely want to buy a Raspberry Pi, I'd suggest you to get this Raspberry Pi Zero that after few months should be priced at $5, or to buy this Raspberry Pi 3 that is the latest version and unfortunately costs about $35. The total price would be even higher if we would set up the Raspberry Pi by using the easiest way that needs a separate display, keyboard and mouse that are connected to the Raspberry Pi. This my Windows 10 computer is quite new and practically it is still at its factory settings. So it is a good environment for these kind of tutorials. And we see that this Windows 10 computer already has a very good user interface, and I wasn't at all willing to bear the cost of any extra display or keyboard or mouse just for turning such a tiny Raspberry Pi board on. So, in this video I want to show you that all you need to get your Raspberry Pi working is an Ethernet cable, some 5-volt power source and one microSD memory card. From the description below you will find these good setup instructions. Let's place those instructions onto the right side of my Windows 10 computer screen. And we are led to know that for a Raspberry Pi we need an at least 8 GB microSD memory card. At eBay they cost about $1 or $2. And if your computer doesn't have any microSD card reader, you need to buy one. At eBay they cost less than $1. So connect your microSD card first into a Windows 10 computer. If that card already has some of your important files, copy those important files to somewhere else, because next we delete all the files that possibly were stored into that microSD memory card. At the Windows File Manager, right-click the microSD card's icon, choose Properties and check the file system of your memory card. If the file system isn't FAT32, use this freeware program and see these instructions to reformat your disk. When the file system is FAT32, there shouldn't be any need to format it anymore. Write down the letter that at your computer is after the name of the microSD card. You'll need to remember that capital letter after a while. So, an Arduino Uno has a bootloader. My laptop computer here has Windows 10 operating system, and respectively a Raspberry Pi needs some kind of an operating system. As an example, we download and use this Raspbian Jesuit Pixel operating system. Choose the zip file, download it to your Windows computer's download folder, right-click that zip file and choose the 7-zip program to unzip that file, for instance, to that very same download folder, and you see that a new file with an EMG ending has appeared into your download folder. Next, you'll need this Win32 disk imager freeware program. Download it, it is an exe file. So, to run it, you just double-click that downloaded program and allow it to make changes to your computer. Make sure that the hard disk's device letter is the same letter that you wrote down a minute ago. Click that blue icon, navigate to your download folder and double-click the file that you just unzipped and that has the EMG ending. Click the Write button, and before you confirm your choice by clicking the Yes button, check once more the hard disk's device letter. If the letter of the hard disk is not the same as the one that you wrote down, you probably would damage your computer now. The size of this operating system is somewhat more than 4 GB. The progressing of writing process can be seen here, and it will take from 10 to 40 minutes depending on the type of your microSD card. When the process is ready, click the OK button and then the Exit button. Next, we must enable the desired remote access that uses the Ethernet cable. To do that, navigate in the File Manager into your microSD card. The hard disk has still the same letter, but now you see that its name has changed to boot. Double-click that boot disk and you see in that disk several folders and files of your brand new Raspbian operating system. Below the last one of those files there is an empty area. Right-click over that empty area and choose to add a new text file. Add the suggested name of that file, leave that point as it is, but delete the txt ending. Don't write any new ending to that place and change the proposed name of that file to SSH, written in small letters. Hit the Enter key and then confirm your choice by clicking the Yes button. And now your Raspberry Pi is going to accept the Ethernet connection that we are going to take after a while. So we are ready with the microSD card. At the File Manager, right-click the hard disk icon that still has the name boot and choose to eject the card. And now it is safe to remove the microSD card from the reader. Place the microSD card into the Raspberry Pi's memory card slot so that the small metal pads of the card are facing towards the green surface of your Raspberry Pi. You should feel a click when the card is in its right place. Your Windows computer is probably already connected to your home router. So take the Ethernet cable and connect also your Raspberry Pi to the same home router. And finally, we must somehow power up our Raspberry Pi. It needs up to 750 milliamperes of current. These mobile phones' power banks and these phone chargers all have 5-volt output and seem to be able to give the needed amount of current. Any of these power sources will do. There is only one micro USB socket on the Raspberry Pi 2 board. Connect the power source to that socket with a suitable USB cable. So, let's now try the Ethernet connection. To take that connection, you need to know the IP address that your home router has given to your Raspberry Pi. So, download this freeware Advanced IP Scanner program. It is an exe file too. So, just double-click that program, choose the installation language, press the OK button, choose to run the portable version of this program, choose to accept the end-user license agreement, press the Run button, and in this final screen press this Scan button. Among the scan results, write down the several numbers and 3 dots that come after that Raspberry Pi word. Now, go to this website, click this link and install this PuTTY program by using everywhere its default settings. Open the PuTTY program, type into this box the IP address that you wrote down a minute ago. Click Open, click the Yes button of this pop-up window, and now you see that the Raspberry Pi is working and that it is talking to us. For this operating system, the default username is always Pi, and the default password is Raspberry. Write them here with small letters and change them later to your own ones. Now, write to the PuTTY's command line sudo raspi config. That is a Linux command where the sudo means that we, like an administrator or as a super user, want to do something. In other words, we emphasize to the computer that we are the person that is allowed to do anything and everything to this our own computer. And the actual raspi config command obviously stands for Raspberry Pi configuration. We now get to a simple menu. At this line we could change the username and password to our own ones, but I do not change them today in order to make this video easier for you to follow. Using the arrow down key, navigate to this line. Hit the Enter key in order to ensure that whole of the micro SD card will be at our disposal. After that, hit the Enter key once more. Using the arrow down key, navigate to this line and hit the Enter key, and continue with the arrow down key to navigate to that VNC line. Those letters stand for Virtual Network Computing. Hit the Enter key and in the next screen hit the tabulator key of your keyboard so that the Yes option turns to red, and then hit the Enter key. And hit the Enter key once more to confirm that choice. Using the tabulator key, go to the Finish option and hit the Enter key. We are asked to reboot, and by hitting the tabulator key and finally by hitting the Enter key, we answer yes to that question about rebooting. My laptop computer starts complaining that it has just lost the connection, and that is understandable as we have just shut down our Raspberry Pi. Click that OK button and close the PuTTY's black window too. Now download a VNC viewer from this site. That site seems to notice that I am using a Windows operating system and that my computer can handle 64-bit computing. The website proposes me an exe file for downloading. I click that file, and when it has been uploaded, I double-click the exe file. I am asked to confirm here that I have read this text and click OK. I usually don't allow any of my programs to send data from my computers by its own, so I click to unchoose this Send Anonymous option and then I click that I got it. And finally, at the program itself, write to the address line the IP address of your Raspberry Pi, and now you have an excellent graphical user interface to your Raspberry Pi. Choose Raspberry Pi application menu, Programming, Genie Programmer's Editor. There choose File, New with Template, main.c. Into that empty line number 29, write printf hello YouTube using this syntax. Now move the cursor over the brown icon that looks like a building brick. Click that icon to build the current file. You are asked to save this your new project somewhere, so navigate for instance to the desktop folder and at the topmost line give some suitable name for your current program. For instance hello.c, and then click Save button. You hear a sound and see a message from the compiler that the compilation has finished successfully. Now move the cursor over this other icon that looks like a white paper airplane. Click that icon to run the current file. An LX terminal window appears, and there on the first line we see the desired words Hello YouTube. Our first C program seemed to be a success. And from this USB memory stick I show you the program that was blinking the GPIO 13 pin in the beginning of this video. It is a C++ file and I copy it into the desktop too. As we know, this program uses GPIO pins. It needs a specific library for that purpose. So choose Build, Set Build Commands, and at this box tell to the compiler about an additional library and the name of that library. And do the same for this second box as well. And because such a GPIO pin library obviously uses quite fundamental features of a computer, the compiler needs the authorities of a super user to do such things. If I now compile and run this program, everything goes as earlier. The LED blinks and the system reacts to a button pressing. Here I use these two other wires in order to shut down the whole Raspberry Pi. And after such a decent shutdown, it is now safe to detach the power supply of a computer. By reconnecting the power supply, the Raspberry Pi starts running again, and the only thing that is left for us today is to make our C++ program to start running automatically after each new power-up. So, look at the desktop folder where we saved the CPP file. As we did the compilation and building with the default settings, we now see that in that same folder there is a new file that hasn't got any extension at all, but has otherwise the same name as our earlier CPP file. That is the executable file that the compiler and builder have just made for us. Copy the path to that file by right-clicking that file and then by choosing Copy Path. Open the terminal window and write sudo nano etc rc local using this syntax, and you get into this simple text editor. Hit the arrow down key so that your cursor gets to this first empty line. Write to that line sudo, then hit the spacebar once and press simultaneously the Ctrl, Shift and V keys to paste the path of our executable file into the ending of that command line. to write out and to save this modified version of our text file, press Ctrl O, accept the suggested old file name by hitting the Enter key, and finally exit from that text editor by pressing Ctrl X. Now click Raspberry Pi application menu, shut down, reboot, and see how our Blink program starts running by itself after every new power-up. In this video, we used the latest Raspbian Jessie image, so this our system is relatively up to date. But if you later want to update your system, and if you want to do the upgrading through your Ethernet connection, see the description of this video for some good advice. So, thank you for joining me today. Most of us have started using Arduinos because the word of Arduino Uno is so easy to enter in. I hope that today's video encourages you to get acquainted with microprocessors and other microcontrollers too. Have a nice evening. Goodbye.